I should have. Then I got
Okay, here we are, the end of week 3. Do we know what's in 5 days? Quiz, right? Our first quiz, which should be the easiest quiz, should be one we're all gonna ace it, right? Okay, I mean, I couldn't set you up any better, really. And then don't forget Thursday, we have a lecture on Thursday. Wait, is this week 4? Yeah, week 4. So the Thursday would be the 26th, but today is what, the 19th, so 7, that makes sense. And we don't have any homework due on Tuesday, we're just preparing for the quiz, but after Thursday's lecture, a week from today, you do have homework due on October 1st, 5 days after that. So there's the plan, there's where we're at. Let's see. Here's the homework that's posted, but since it's not due, I'm gonna post the answers, I don't know, tonight or tomorrow I think tomorrow at the latest, hopefully tonight. So right now you have the questions. If you want to challenge yourself to try to answer those, I'll have the answers posted so you can compare to the answers. Let's see. I want to review something. So I need to go to, what was the you got the 3 slide numbers for the 3 main confidence interval calculation formulas, right? For example, slide 10 for the Z when it has to do with the mean, right? And then slide, here it is, 18 for T when the standard deviation is the samples, again with the mean though. And then 26 is the proportion formula. But what was brought to my attention Tuesday that I forgot to review, I want to make sure that you realize what part of this formula is the margin of error and what part is the standard error. Okay, now there's standard error of the mean, there's standard error of the proportion, but they're both called standard error. And they're both the same part of each of the formulas. So as we look at this proportion formula, how are you going to describe to me what the, let's call it the margin of error would be from a certain point to the right? Plus or minus. From to the right of the plus minus is margin of error. There it is. That's how you remember it. On all of these. Doesn't matter which one of these 3 formulas. From the plus minus to the right. To the right of the plus minus, that's margin of error. But what part of this formula, how would you describe then the standard error?
Square root and unit.
To the right of the Z or the T. Everything to the right of the Z or the T. In this case, to the right of the Z. So that whole square root is the standard error of the proportion, because it's proportion, but it's called standard error. If you just write standard error, if I'm asking a question about this and you just say the word standard error and don't identify whether it's the mean or proportion, I'm okay with that. I'm so happy that you're recognizing it with standard error, I'm going to accept that. But this happens to be called the standard error of the proportion because it's a proportion formula. Now let's go back to this one. To the right of the T, that's the standard error of the mean, because this is a mean formula. And then this one, to the right of the Z, is the standard error of the mean, because this is a mean formula. So 2 of them are standard error of the mean, and the one we learned Tuesday is standard error of the proportion. The whole point of this is you recognizing that all 3 of these have both, and from where to the right are they? So if you had to calculate, you knew which exactly numbers to use. Now, I want to talk about this one from week 1, which is when the population standard deviation is known, but we're skipping this one where the standard deviation is of the population is unknown because we have the standard deviation of the sample. So we're skipping this one, and we're talking about this one, the proportions, when it comes to these 2 formulas today. These 2 formulas today are how to find the optimal sample size in order to have the amount of confidence in your confidence interval. Based on however much confidence you want to have or however much error you're willing to have, this tells you then exactly what your minimum sample size should be. This will be the least amount your sample size has to be. Now here's the weird part. When you calculate this, this is called the mean sample size, or minimum sample size or optimal sample size, however you want to put it. This one's for the mean, this one's for the proportion. I want you to be careful. Everything is squared in the one for the mean. Z is squared, standard deviation squared, the given amount of acceptable error is squared. And when it comes to the mean, that acceptable amount of error is given to you in the number of units. As a number. Like 3, plus or minus 3. We want to know with confidence the confidence interval plus or minus 3, plus or minus 5, plus or minus 10, stuff like that. It'll be given in units. With the proportion sample size, minimum or optimal, whatever you want to call it, the Z is squared, the E is squared, the error, but the proportion times 1 minus the proportion, that is not squared. So be careful. All 3 parts of one formula squared, but only 2 parts of the other formula squared. The proportion times 1 minus the proportion is not squared. The standard error. I'll just call that the standard error. Well, it's not. I'm sorry. The proportion times 1 minus the proportion. Forget what I just said about standard error. Now, the E, the error, amount of error being given to you in the story is a percentage when it comes to proportions. And they're willing to accept 2%, plus or minus 2%, plus or minus 4%, plus or minus 6%. This has to be written as a decimal. Let me repeat that because this is where you'll blow it. In this formula, that E, the amount of error, acceptable error, has to be written as a decimal. So if it says plus or minus 4%, this would be 0.04 squared. All right, there's that. This is just, now let me go here. Here it is, determining the sample size for the mean, for the proportion. There's 2 different formulas. By the way, how do you tell the difference? The one for the mean will have a standard deviation. The one for the proportion will not have a standard deviation at all. Same way you recognize which confidence interval formula to use is the same way you recognize which sample size formula to use. One has a standard deviation, the other doesn't. All right. So if you notice, here's what's happening. You're taking the original formula for the confidence interval and you're just kind of switching it a little bit and you're bringing in how much error is allowed. This will make sense in a minute. And then after you do the little switching, you then take the error and insert it into the formula and bring n, the sample size number, to the outside. So it's just using algebra, but basically this is what you want. You want slide 33 formula in the bottom right-hand corner. That's exactly what I have here at the top. Z squared times standard deviation squared divided by E squared. That's the formula in the bottom right. That will give you the optimal number when for a mean, for a confidence interval for a mean. It will give you the sample size, minimum sample size, I guess you call it. All right. Now, same thing with proportion. Is taking the proportion formula. This looks familiar for confidence interval. Again, bringing the E, bring it there, bring the sample size to the outside using algebra, and you end up getting the Z squared, the E squared, not the proportion times 1 minus the proportion. That is not squared. And this will end up equaling the sample size. So there's how the 2 formulas came about. So slides, where are the formulas at? Slide 36 and slide 33 are the 2 numeric formulas to find sample size that you're going to use. I'm using words instead of symbols. It's the only difference. Because the symbols switch so many times to these, I don't want you to get confused, so just use words. So let's go to our first example. I'm going to go to a proportion example. Go to slide 38. How large of a sample would be necessary to estimate the true proportion of defective parts or defects in a large population with plus or minus 3%, and you want 95% confidence? Assume that the sample proportion yields 12%, 0.12. You have all the numbers necessary now. Here's the setup. Here's where all the points are, the setup, and then you gotta show me some math. First of all, am I using the top equation, sample size for a mean, or the bottom equation, sample size for a proportion? Bottom, exactly. So, how are we gonna find Z? You're gonna be, if this is a quiz question, and it will be, you're asked to give me the Excel equation to find either Z or T. But there is no T to find. It will probably just say, give me the Excel equation to find Z. So lately we've been using, here they are, norm IMV and norm SIMV. Let me go back to norm S, because this is the one that seemed like everybody liked on the homework. And that's where you only have to put in then the confidence plus half the significance. Where over here, if you use norm IMV, you gotta use the first number is the confidence plus half the significance, but the second number is 0, the third number is a 1, always. So you just save a little work if you wanna use the norm S, and you just put in the confidence plus half the significance is your first number to find Z. So help me write this one. You said we're using this bottom equation. The first part of, this was the homework question or a quiz question, is I gotta give the equal sign for the Excel equation. I'm using the NORM.S.INV. Help me out. This problem, I already forgot, so don't tell me, hang on, I gotta remember, I gotta look. Okay, this problem, I see now how much confidence this problem's asking for. So the number inside the parentheses has to be 0.1. Not all at once, we are recording.
975.
Oh, there we go, wow, exactly, 975 parentheses. Because it said 95% confidence, the significance is the opposite 5%. We divide the 5% in half, which is 2.5%, add it to the 95. 97.5%, 0.975. We put that in Excel, which I was not prepared. Hang on, let me open up. Let's do it right on here. You know what, is there one on here already for 90s? What is it, 97.5, there it is right there. Equals norm S IMV 0.975, and I see that it ends up being 0.9599. So we can't go 3 digits because we got all those 9s there. So I'm gonna go ahead, what is it, 1.9555? 959, 960, I'm going like that. 1.960, there's our Z. I'll put right here, Z equals 1.960. So now I can set this up. Let's go back to the problem. That's all I had to do. Is that me? Whoop, whoop, whoop. All right, help me set it up. Starting here, Z squared 1.96 squared times, what proportion am I putting here?
0.12.
There you go, 0.12, 12%, 0.12 times, parentheses, 1 minus 0.12, parentheses, over, hang on, this is not writing very well, come on, over, what's on the bottom?
0.03.
I heard you say it.
0.03.
0.03, 0.03 squared. Z is being squared, that error is being squared, and then your proportion. There's the setup. There's where most of the points are, right there. Showing me this Excel equation to get your Z, setting up this equation to get the sample size number, then you do the math. You're gonna show me at least 2, you could show me Z squared, you can show me E squared, or you can show me 12% times 1 minus 12%. I need to see at least 2 details of math between the setup and the answer.
That E, it represents error, not
Error.
Not E like on a calculator.
No, not E on calculator, error. I'm putting either, I should be putting error, shouldn't I? Put the word. There, error. Am I spelling it right? R-R-O-R? Okay, error. And it'll be given to you. It'll be obvious, this problem on a quiz will be obvious. It will say, hey, what's the sample size you should use to have 95% confidence when you're willing to have to be within plus or minus 3%, and your sample yields a proportion of 12%. Nothing there about standard deviation. It was asking for sample size. You know it's one of these 2 equations. Boom, you notice this bottom one because there was no standard deviation. Now you gotta start with giving me the Excel equation to get your Z, do your setup. There's a whole bunch of points, there's most of the points right there. You're now gonna show me at least 2 detailed calculations and then an answer. Now, here's the bad news about the answer. You ready? You ready? Let me answer your question. Look at what we get, 450.74. That can be 450.01, and here's the weird part. You must round up. Oh my God, I gotta put that in big letters. Round up, no matter what. Let me say that again. That could be 450.1, and you gotta go to 451. You can't go down to 450. This is the least amount you can have. So you're gonna have to go to 451. That's the least amount you can have now.
Is that for both?
For both, you gotta round up. Both the equations.
So we gotta solve it further, that's what I was gonna ask.
Yeah, you gotta solve it, and then you gotta round up. But in here, you gotta show 2 calculations. Maybe that 0.03 squared, or maybe the 1.96 squared, but I need at least 2 calculation work. I need to see details, just like the homework. So, Jason, is it you?
So
No?
like 0, 0, 1 would still be round up, always round up, right?
Yeah, even if that were 450.0001, you gotta round up to 451.
So if it was a flat 450 though.
Then you're fine, but the odds of that are slim.
So if there's just any decimals round up.
Any decimal, you gotta round up. That's the weird part. It's not normal. It's not normal rounding for sure. All right, let's find one with a mean involved. Hang on. I think I got one here, don't I? Oh, wait, what's going on here? Right here, let me see. No. Shoot. I'm going to add error to this one right here. I'm gonna pretend, let me see, the standard deviation is 4,500, the 7,790. I'm gonna add to this problem, plus or minus $950. I don't need the dollars there, units, but it's in dollars. Plus or minus 950. So that's the only thing not in these instructions is that sentence. It will say, hey, calculate the sample size for this problem based on a sample of 100 consumers. The research finds an average amount spent on a debit card, 7,790. Assume the population standard deviation is 4,500. What would be the 99%, or what would be the sample size if you want 99% confidence with plus or minus $950 in error, of possible error? Everybody hear that? There it all is. What do we start with? What should we do first? Very good. Nick's all over that. You ready? Z equals norm dot S dot I N V. Someone get this on a thing so you can tell us. Well, maybe it's on our thing. But here we go. What was the confidence? I see it, so I need to put 0.9. Help me out.
95.
Very good. Who was that? Very good. No, it's all over it. All right. He took 1% significance, split it in half, which was a 0.5%, added it to the 99 to get 99.5%. 0.995. That's the tricky part about that. So I think we have a 995 on this already. Is that 995 right there? Norm S 995. So I'm going 3 digits. What should it be? 2.57 what? 2.57. What's the next digit? 6 it is, because there's an 8 after that. Very good. 2.576. So now we're going to set it up using this top formula. 2.576 squared times. What's standard deviation? We gotta go back to the problem.
4,500.
Yeah, I think it is. Well, close your eyes. You didn't see that one, did you? That's your ink class. 4,500. 4,500 squared divided by 950. The error that I mentioned here, plus or minus 950, and don't forget to square it. There's the setup. Define the sample size for a mean. I want to see if the PowerPoint has an example for a mean. Either I can't find it or I passed it up. Hang on a minute. Oh, right here. Okay, here we go. Here's another one. If the standard deviation is 45, what sample size is needed to estimate the mean within plus or minus 5 units? 5 right there. With a 90% confidence, okay? We went ahead and would do norm S, I, and V. What would be in the parentheses for this problem? Anybody? 0.9. Wait, what'd you say? Hang on. No. That's the Z. Yeah, what's in the parentheses though for the norm S, I, and V? Point? No, 0.95. 0.95, because half of 10% of significance added to the 90. 0.95 gave us a Z of 1.645, very good, which would be squared. Standard deviation is 45, there it is being squared right, where's my pointer? There. And then there it is, it gave you the plus or minus 5 units error, there it is at the bottom, squared. You're showing, there's the setup, you gave me the Excel equation to find that 1.645. By the way, guys, this is slide 35. And then you're showing me at least two calculations now that you got it all set up. You get 219.19. You're in a hurry. You go, oh, 0.19. I'm rounding down to 218. No, or 219. No, you forgot. When it comes to the sample size, you always round up. So this guy has to go to 220. And believe me, that's part of the question. Showing me that you knew to round this up. That's another quarter of a point at least.
Is that 4,500 or 9,500?
That's 4,500. Hang on.
Basically, there's any decimal.
There. Is that better? That's from this. This was from this problem right here. 4,500 standard deviation. That's where that's from. All right. I want to do another example of. Let me think here. Oh yeah, our homework has it. Where's our homework? I think it's problem 39. It's got to be problem 59. So let me see. I have pictures here. It's 59, and this one it is. Here we go. All right, we're going to do part of your homework right there. I'm going to make it nice and big so we can see it. There it is up at the top. In the planning stages, that it says, in the planning stage, sample proportion is estimated to be 40 out of 50. Look, it may say, hey, we had 40 successes out of a sample size of 50. You gotta remember to take 40 divided by 50 and find that proportion. That's where a lot of you will get stuck and you'll get stuck on that first step. Let me repeat that. Because this is what happens when there's a question where it's not giving you the proportion, that you have to calculate the proportion. It will say something like, there are 40 people left-handed out of a sample of 100. You're going to take 40 divided by 100 to get that proportion. So in this case, it's giving you 40 out of 50, and it literally calculated for you 80%, 0.80. Use this information to compute the minimum sample size, which is going to be n, required when you want to estimate a 99% confidence. And your desired margin of error is 12%, plus or minus 12%. You ready? And then it says, what happens if you decide to change the confidence to 90%? Let's just start with 99% confidence. 12% error, 80% is our proportion. Are you ready? What's my first step? Find the Z. So which formula are you using, top or bottom? Bottom, because it's proportion, very good. Okay, we're starting with 95% confidence, is that right? 99, is that right? 99. So the number here is going to be again 995, which means it's going to be just like before, 2.576, which means this turns into 2.576 squared. The given proportion is, how much is the given proportion? 80%. 0.80 times 1 minus 0.80, and the amount of error, 0.12 squared. There's the setup. Oh my God, this is almost too easy. I can't believe you guys aren't sleeping. They're not sleeping. I know we can only see the back of the heads of the front row. I looked at the left right here. Let me keep looking here. Show me 2 calculations, come up with that answer here, and then make sure to round up. Hey, you know, I think I have the answer to this one, because I'm about to post it, so I know it's in here somewhere. Right there. Okay, there it is. So here it is right here. 2.5, okay. Let's do it a different way. Here it is. 1 minus 80% times 80% times 2.576 squared divided by 0.12 squared. Here's a little math, I guess. 21.4 blah 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 times 16. 73.73. We have to round up, so the optimal amount would be 74. The only thing that would change, the question then says, hey, switch the percentage from 99% to 90%, is that right? 90%? The only thing that changes if we switch to 90% is this right here, the Z. Everything else stays the same. Switching to Z and 90%. So if you notice, the only thing that we switch here is going from 2.576 to 1.645. Now, look at how different though. Going from 99% confidence, we gotta have a large sample size to have that much confidence in it. But if we're only going 90% confidence, well, we can have a much smaller, or less than half the sample size if all we need is 90% confidence. All depends how important the information is that you're relaying to somebody else. Hey, I have 90% confidence that according to our sample, the proportion in the population is somewhere between here and here. 90% confidence, or I have 99% confidence. Then it's going to be either a much larger sample size or a wider confidence interval. Any questions? Let me look at my notes. That was fast. How are we doing on time? Oh, we're going fast. All right, let's look at one. We gotta look at one more homework problem. The other homework problem was 297, 39 A and B. So let me bring that one up. I think this is it. 39 said a random sample of 80 observation results in 50 successes. Come up with the 90. This is a confidence interval question. You ready? 80 observation resulted in 50 successes. You take 50 divided by 80. Someone get that real quick. It's going to be like 60%, I think. Construct a 95% confidence interval. So I'm going to take 95%. Which will end up being, is this a proportion? Yeah, it's a proportion. So we're going to be norm equals norm dot S dot INV, parentheses, 95% would be 0.975, which we know is going to be whatever. Now, 50 divided by 80, so say it again. 0.625, all right? Now, do we remember whatever Z is, someone get this norm S INV from 0.975. I think that's going to be, did we have that one already?
Yeah, I think we did.
It's not, it's less than 2 so it's, what is it, 1.96? 1.960? Does that sound right? Is that it for sure?
Yeah, that's what it
Okay,
is.
so there's that. Now, don't forget, we're doing the interval right now. We just switched back to Tuesday's lecture. So we're doing the interval. Here's our two numbers. We showed Excel how we got our Z. We calculated our proportion. And now we got to go, let's see, I'm doing this manually. So equals 0.625 plus or minus 1.960 times, right, times the square root. All of this is square rooted. This pen is running out of color, switching. A little better. And we have up here 0.625 times 1 minus 0.625 over, the only thing I don't remember is what's the sample size. Oh yeah, we got the sample size. What size is the sample? 80. There it is. There's the setup. Oh, you know, after doing that problem, I realized we're all going to ace this quiz. We're going to be darn close. This is going to be our best average for a quiz of any. I mean, ever in this class.
I hope so.
We got it covered. We've covered everything. And then this in-class assignment, oh my God, is it gonna prepare you? Any questions? Do we wanna, let's recall the subject since we have all this extra time for free. Week 1 was confidence intervals for a mean when we know the population standard deviation. Week 2 was confidence intervals for a mean when we don't know the population standard deviation, but we're given the sample standard deviation. Week 3 was confidence interval for a proportion and the minimum sample size for both a mean and sample size for a proportion. Those were the main calculating subjects that homework was related to. And if you have, let's say you have 6 problems as far as having to calculate things, 5 of those are probably gonna be directly related to those subjects we just talked about. One of them is gonna be from that whole assessment thing here. I'll make sure that problem's last, so you know it's the assessment problem, and that you will keep it till last to make sure, just to use whatever time's left. And when time's up, show me that that's the only question you have left even, and I'll let you finish, because it's the assessment question. I will send out something on, when's our quiz, Tuesday? So I'll either send it on Sunday or Monday, specific directions. I know a lot of you have had me before, so you know what to expect, but there's some new students who've never had me. Things that are gonna be in the instructions are like, make sure and turn off your phone, or turn off your ringer on your phone and put your phone away. You can only use a calculator that can't be connected to the internet. You can use anything posted on Canvas, but you can't print anything. You can use your notes, but you gotta take pictures of your handwritten notes and turn it into digital to use them. You can't have paper out at all, except for the quiz. You're gonna have assigned seating. You're gonna have folders up between you. You can't have the internet on your computer, any computer. You can only use one computer, either this computer or your own. You can't have the internet turned on at all. You have the internet turned on for a minute to get everything off of Canvas if you don't have it on a flash drive real quick, and then you turn the internet off. Get everything open. I don't know, maybe watch the videos before you, like Monday before the quiz or Tuesday morning, maybe watch the videos again. Look, we're keeping them short.
Is there any other definitions that you want to?
Now, you guys are kind of on your own on definitions. Good luck to you, I think. That may be the only reason you don't get an A on this, is because of those darn definitions. Come on, seriously. All right, and then I gotta turn this off.